High above us in the Earth's atmosphere, powerful winds race around the globe. These winds, known as the jet stream, are like rivers of air flowing eastward at speeds up to 200 miles per hour. The jet stream plays a crucial role in our weather, steering storms and influencing temperature patterns across continents. It forms a boundary between cold Arctic air to the north and warmer air to the south. Think of it as a rope holding back the frigid polar air. However, this delicate balance can be disrupted, sometimes with dramatic consequences. The jet stream's strength and path are influenced by the temperature difference between the equator and the poles. A large temperature difference strengthens the jet stream, while a smaller difference weakens it. This difference is most pronounced during winter, leading to a stronger and more volatile jet stream during the colder months. In recent years, scientists have observed changes in the jet stream, including a tendency to meander more and even split into multiple branches. One phenomenon that can significantly disrupt the jet stream is sudden stratospheric warming, or SSW. High above the Earth's surface, in a layer of the atmosphere known as the stratosphere, rapid warming can occur, sometimes by as much as 50 degrees Celsius, or 90 degrees Fahrenheit, in just a few days. This sudden warming weakens the polar vortex, a swirling mass of cold air that normally resides over the Arctic. As the polar vortex weakens, it can split into smaller vortices or even reverse direction, causing the jet stream to buckle and meander southward. Imagine a garden hose with kinks in it. The water flow becomes erratic. Similarly, a disrupted jet stream can lead to unusual and often extreme weather patterns, as warm air is pushed north and cold air plunges south. The potential impacts of a disrupted jet stream on North America are significant. When the jet stream dips southward, it can bring frigid Arctic air deep into the United States, leading to outbreaks of extreme cold, heavy snow, and ice storms. This can cripple infrastructure, disrupt transportation, and threaten crops and livestock. Conversely, areas further north may experience unusually warm temperatures for the season. The eastern United States in particular is vulnerable to these disruptions. A southward dip in the jet stream can create a sharp temperature gradient across the country, with frigid air to the east and unseasonably warm conditions to the west. This stark contrast can fuel the development of powerful storms, bringing heavy precipitation and high winds. Coastal regions are also at risk of flooding as low-pressure systems, energized by the temperature extremes, draw in moisture from the Atlantic Ocean. We have seen the disruptive power of SSW events in the past. In March 2018, a phenomenon dubbed the Beast from the East brought record-breaking cold and heavy snow to parts of Europe, paralyzing transportation and causing widespread disruption. This event was triggered by an SAW that led to a weakening of the polar vortex and a southward shift in the jet stream. Similar scenarios are possible in North America, and scientists are closely monitoring the potential for future SSW events. While predicting the exact location and severity of these events remains a challenge, the long-term trend of a warming climate is likely to exacerbate jet stream instability. As the Arctic warms at a faster rate than lower latitudes, the temperature difference that drives the jet stream weakens, making it more susceptible to disruptions. Understanding these complex atmospheric processes is crucial for predicting and mitigating the impacts of extreme weather events in a changing climate.